Hello, welcome back to the process management in operating system. And in this video, we are going to follow up with the process scheduling. So we have seen about the process concepts, PCB, and what all the various operations on process can be carried out. So let's move into this process scheduling. Basically, what is the scheduling is we have to schedule the processes which are all competing for the CPU for execution. So here we can have single CPU or multiple CPU. For here assumption we are taking a single CPU which is going to process or execute several processes. So the only concept and the advantage what we need is the maximize the CPU utilization. So all the way when the scheduling is being followed, the CPU utilization should be maximum such that the number of processes executed by the CPU should be of maximum. And here we have various types of schedulers, and these schedulers have their own queues. So those scheduling queues are given as job queue, ready queue, and device queues. So job queue always has the set of all the processes which are all inside the system. For example, where the files are stored in the hard disk, that will be available in the job queue. And now in the ready queue, when the particular program is opened, it will automatically load it into the main memory. So now it will be available in the ready queue, which is waiting for execution. And next, the device queue. So device queue consists of which are all the processes waiting for an IO device operation. Whatever, for example, print queue. We have jobs when we are giving the print option. One by one the jobs will be stored in the printer queue. So those are called as the device queues. So this particular diagram visualizes what are all the various available queues and the IO devices queues with ready queue, etc. So in the first diagram it is given as an ready queue. So in this ready queue we have two jobs named as P7 and P8. P2. Okay, P2. So it means that we have two processes where their PCB are already loaded into the main memory. So that is called as PCB 7, means that the PCB of process 7, and PCB 2 means that PCB of process 2. And this head pointer will always point to the first job which is in the queue, and the tail points to the last job in the queue. So obviously here the first job is P7 and the last job is P2. So the pointer has been set. If there are n number of processes, the pointer will go from first job to second job, second to third, and it's so on. The last job will be connected with the tail pointer. And we have a next unit called as magnetic tape unit 0. So we'll be having lot of queues inside a particular device. So here the IO device is taken as magnetic tape, where I have two units assumed. So unit 0 and unit 1 means that here unit 0 doesn't have any process in its queue, and unit 1 has no process in its queue, means that we have not taken any of the files. And the next one is called as the disk, which means that hard disk. So in this hard disk again we'll have several units. In unit 0 we have 3 processes in queue. So process 3, process 14, process 6. So these are the 3 processes available in the disk unit 0, where the head pointer points to PCB 3 and the tail pointer points to PCB 6, and within that the pointer will be connecting to the intermediate processes. So this is the diagrammatic view of all the our IO device queues and the ready queue. And here how this process scheduling happens. This particular diagram gives you how the queuing model happens here. So let's have the CPU which is circled here, and in the ready queue whichever job enters into the ready queue, it will be processed or executed by the CPU. After its completion it leaves out, that is the arrow mark given at the right side. And this ready queue has another arrow mark which means that jobs will be incoming. And meanwhile, during the execution inside the CPU, if the process needs any of the following, IO request or time slice expire, or if it creates a new process, means that creating a child process, or it wait for an interrupt, In all of these cases, automatically it is preempted from the CPU and it will be given to the appropriate queues. If it is an IO request, it will be passed to IO queue. If the time slice expire, it will be moved outside through this time slice queue. So likewise, we have 4 set of queues, and this particular queue holds the data and it will be given to the ready queue. When this time slice expire happens, after this time is over, that particular job will be again sent back to the ready queue. This means that the time has expired but still it is in the CPU without executing. So it will be pushed out and again asked to wait in the ready queue at the last. So this is what, after this child is created, when the child executes and completes, then that particular process will be made available in the ready queue. And when an interrupt happens, till the interrupt is processed, it will be waiting there and it will be sent back to the ready queue after it's completed. And these are all the various types of schedulers: short-term scheduler, long-term scheduler, and we'll have one more scheduler called as medium-term scheduler in order to process it very fast. So short-term schedulers are always called as the CPU schedulers, and long-term schedulers are always called as the job schedulers. And these job schedulers are always working in the ready queue, and the short-term scheduler or the CPU scheduler holds the major work which selects the process should be executed by the CPU, and the allocation is carried out. Thank you.